Hello everyone, welcome to Maths Easy. Today we are going to discuss a typical Kirchhoff's law question. A question where you need to use both Kirchhoff's first law and second law to get the answers. Um, in this question, you have a slightly complicated circuit with 4 resistors and 3 power supplies. So obviously, you cannot simply do this question using your normal I equals E over R plus R or basic V equals IR relationship because of the complexity of this one. So you have to use Kirchhoff's laws. Now, the first thing you need to do in a circuit like that is to use Kirchhoff's first law and mark the current in the circuit. Now, there is no right or wrong place to start it because you're just going to use algebra to just get some letters. So you can start from any place. However, in my experience, it's always helpful to start from the biggest power supply because then you are less likely to get negative answers. Because, the other power supplies will not be able to push current into the biggest one. So I'd rather start from the big one here. So here you got two big ones. You can start out from any one of them. Let's start from maybe from here. Okay. So let's say the current coming out from here is capital I, same current, and I. And the current goes to this junction, and now there is splitting up of current. Now let's say the current goes in this junction is lowercase I. The current goes through this part is I take away I because the sum of these two should be I. Now I minus I here and through this one. Now this lowercase I comes through this and comes here. And now you can see in this junction here, I minus I plus lowercase I gives you capital I. So if you get the same current as whatever you started with, you're on the right track. So that's the first thing you need to do. The second thing is we need to label the circuit. So let's label it as A, B, C, D, E, and F. Now, to use Kirchhoff's second law, we need to find a complete circuit, a complete loop. Well, there are three options here. I can use this loop, or I can use this loop, or I can use the big one. So you'd actually need two of them because there are two unknowns. You need two equations that you're going to solve simultaneously. So we can use the one on the left hand side is the big one, the one on the right hand side is the big one, or the left and right hand side. There's really no right or wrong way of doing it. You can do it either way. Now, let's define our loop first. So when you get the loop, you have to start and end at this with the same letter. So let's get the one on the left hand side. It will be A, B, C, F, A. Now it's really important that you start and end with the same letter. Let's mark the direction from here to here. Now, one of the things that I've seen that students do is sometimes when they mark it, they don't write all the letters. What they do is they call it A, B, C, F. Well, A, B, C, F is not a complete path. Can you see that? So I have to come back to A. So I think this comes from the habit where in maths, for an example, when you draw a rectangle and you call it A, B, C, D, so you just tell the 4 points. But in this situation, please make sure you have to start and end with the same letter so that it shows the full path. So A, B, C, F, A is my full path. So I'm going to write sigma EMF is equal to sigma PD. Oh, now the way to do this one, you have to think about walking. Imagine you're actually walking along this circuit. Now first, let's walk and pay attention to my EMFs. So You're starting from A, and I'm just walking now. That's not an EMF. No, no EMF still. No EMF still. Nothing. Oh, here's an EMF. Now, this EMF is pushing the same way I'm going. So that's a positive one because it's helping my journey around it. So that's a 5. So let's write the value 5. And let's continue the journey now. That's not an EMF. That's, oh, there's another one. Now that is also helping me. So that will be another 5. So I can write 5, add 5. So I'm done with my EMFs because I did a full circle, started from A all the way here, and I came across 2 power supplies that are actually helping me, pushing me the direction that I'm going. Okay, so that's one. Now sigma PD, now I have to do a separate walk. Now just think about it. You can just run your finger along it really, right? So you start from A. Now here's a PD. That's 2I. So let's write it. 2 capital I plus. Here's another one. 6 capital I. Let's write that. Now just going around it, nothing. There's nothing here. There's nothing here. Oh, that is 1 lowercase I. So lowercase I or 1I. And I'm just checking. No, there's nothing else. That's it. So we have 5 add 5 is 10 is equal to 2I add 6I is 8 capital I plus lowercase I. This is my first equation. Now I'm going to do the same with another loop. Now, like I said, you can do the big one or the one on the right hand side, anything. Let's do the one on the right hand side. So let's start it from here then. F, C, D, E, F. Remember, starting and end are the same. You can go like that. Okay. Now, again, I'm going to do the sigma EMF is equal to sigma PD. Sigma EMF is equal to sigma PD. Now, let's do the walk. Starting from F, I'm going here, no EMF, no EMF. Oh, there is an EMF. Now, look at this one. This EMF is pushing the opposite way. I'm going from F to C, but it's going the other way. So I have to put -5. Why? Because it's pushing that way, but my walk is from F to C. Okay, let's continue the walk. No other power supply, no other power supply, no other power supply. All right, this one is actually helping me because I'm going this way and it's going the same way. So -5 add 2. So that's all. When I reach to the starting point, that's all I got. Now, let's do another walk. Now, this time around, we are looking at PDs. Now, starting from F. Oh, there's a PD. Now, look. Remember in the first one, we took this one as 2I. And that's because the current is going the same way that I was walking. I was going from A to B. Now, in this example, you can clearly see the current is going the opposite way. So, it's 1 lowercase I, but it's opposite to the direction I'm going, so I have to call it -I. Okay, let's walk through this. I'm only looking for power PDs this time. Okay, oh, there's another one. That's 4I minus I. So let's do this one. That's positive because it's the same way I'm going. 4I minus lowercase I. Let's complete the walk. Nothing, nothing. There you go. That's it. Okay. Now we have 2 simultaneous equations that we are going to solve. So here you go 10 equals 8 capital I plus lowercase I, then I got negative 3 is equal to negative 5I plus 4 capital I. Now, the physics part is really that, and to find the current in each branch, I need to simultaneously solve it. So I'm sure all of you know how to do the simultaneous equations. I'm just going to do a quicker way of doing it on this side anyway, but please don't worry about it. I'm just going to quickly get the answer and then show the final answer from there. Right, here's the simplification. So this is actually a quicker way of doing simultaneous equations. Most people do how you've been doing it since GCSE time, but if you want, what you can do is 10 equals 8 capital I plus lowercase I. So I made 8I the subject, 8I equals 10 minus I here. Then I did the same thing with the other one and made 4I the subject, and you can just divide equation 1 by 2. So I do the left hand side is divided 8I over 4I equals 10 minus I over 5I minus 3. Now 4I and 8I, that gives you 2. Now I got rid of capital I. So all I need to do is just the cross multiplication, and I got the lowercase I as 1.45 amps. Now all I need to do is substitute it in one of the equations, maybe 2, to get the value of capital I. So after the substitution, now you can see capital I is 1.07 amps. So we got both values, 1.45 and 1.07. Now the question is, find the current in each branch. Now let me get a small diagram of this on the right hand side and show you how the currents work. Now I'm not getting like all these power supplies and resistors and everything, just a simple diagram so that I can show you how the current works. So let's mark the current. So capital I we know is 1.07. So I can see it's coming out from this one. So that's 1.07 amps. Goes through this, 1.07 amps. Okay. Now I know lowercase I, which goes in the middle branch, is 1.45. Okay. So that's 1.45 amps. And this one is 1.45 amps. Now, what's the current in this branch here? That is capital I take away lowercase I, which is 1.07 take away 1.45, which gives a negative current. So I minus I here, this one, is negative 0.38. Now what does that mean? That means the current is not going in this direction, right? It's going in the opposite direction. So in the original circuit, we marked that current from going from like right to left, but it's really going from left to right. Okay, so let's add this to here, to the right. So 0.38 amps this way and 0.38. Now let's see if the Kirchhoff's first law works with all the points. So if it works, then we know we are right. Now 1.07 amps go like that, 1.07, 1.07. Okay. Now also we have 0.38 coming from this side. So 1.07 add 0.38 gives you 1.45. So that 1.45 go through this branch, and then this 1.45 split, and 1.07 go this way, and 0.38 go that way, and that completes like that. So everything works. So we just worked out the final answer. These questions are a little tricky, so I think some of these are slightly on the challenging side, to be honest. But if you understand how it's done, it's actually relatively easy. So my advice is, once you finish watching this video, go back to the beginning, copy the circuit in a nice piece of paper, and then pause the video and try it yourself. The same question you just saw. because it's a bit complex. And then see if you can figure it out. Then you can just play the video and have a look. If that kind of does not, give you the correct answer, if you made a mistake somewhere, just go back and see where you went wrong. I'll get to a couple of more examples, and then those questions you can try even before you watch it, but once you get this one right.